Good afternoon. I'm going to run through this pretty quickly because we've got a lot to cover. A little bit about our company. We've basically been around this business, or I have, for over 40 years now. Been in the software business going way back to when Randy and I were back at QuickPen days, so been around quite a bit. Who is Siskiyou? What do we do? We're basically a developer of BIM systems that is going to allow you to go ahead and build to a level of development of LOD 400 and 500. We have customers that range anywhere from engineers to contractors. We have office locations in Sacramento, California, the UK, and Mumbai. And what do? We provide fully constructible Revit models with real-world information and intelligent components inside Revit. So we don't take files in and out of Revit. We're actually drawing inside Revit with the real-world information. And we'll talk about that in a little bit. Our partners are obviously Autodesk and Trimble. We work very closely with them. We have resale partners outside North America. PARS is in Brazil, CAD Group is in Australia, BIM ES is in the Middle East, and Amtech is in the UK. We have a lot of industry that we support, and obviously part of CAN BIM, besides the MCA, NECA, SMACTA, and so forth. We'll be at RTC. We attend Autodesk University, so we're quite active in associations. So one thing that I like to talk about, and I'm sure does everybody understand LOD, levels of development here? This thing's jumping back and forth on me. What we like to say and where we live with our SYSQUE product is the LOD 300, 400, and 500. And those are basically where you want to be to develop your drawings for fabrication and construction. So there's some typical workflows that I'd like to go through. The traditional workflow, which was basically your plan and spec workflow, was where your engineers would develop the drawings. They'd basically throw them over the wall to the guys that were going to coordinate it, and then finally they were thrown over the wall again to the construction side. Well, there is a workflow now that's starting with the use of Revit, and the engineers are designing in Revit today, but without SYSQUE, they're throwing it over the wall only to have it thrown away in most cases and redrawn. What we like to say is happening now with a native Revit workflow is that the engineers can design, and then we can take that right through to coordination and construction. And that's really the sweet spot of SYSQUE, is to be able to do that, so you don't have to jump back and forth between varying platforms. So what is SYSQUE? SYSQUE is based upon all this data that we've created, and there's like 3.6 million items that are from manufacturers that we've gone out and we've built. The geometry is correct, the sizing, the connectivity is correct. We've added MCA labor to it. We've added Harrison pricing up here in Canada. It's all Pricer, and the actual link back to the web page of the manufacturer is included in that. So SYSQUE is basically drawing inside Revit with intelligence that's going to allow you to go ahead and manufacture from it. So when you start to take a look at drawings like this has actually been drawn in Revit, both of these. When we get to this teaching hospital, it was an engineered file, and then eventually with SYSQUE we were able to put all the parts and pieces in based upon the pressure classes that were necessary for this job, including the hangers that were going to go up. So we like to take a LOD going from design, LOD 400, and then finally installation, as you can see right there. Also doing some examples. On the left you see just generic Revit. On the right was SYSQUE. Same way with the piping. Left, generic, right was SYSQUE. Here's a facility in Stamford, Connecticut, where we took generic Revit piping. We're able to give it all the configurations for the proper system, and then eventually we're able to spool this and send it right down to the fabrication for the contractors to fabricate all of their spool sheets right out of Revit, not having to take it someplace else, but right out of Revit. The next one, here's some real content. You can see this is a shaded view. That's what it was installed. Again, going back here, that's the Revit model. That's what was installed. So taking it again to the field. Underground plumbing works the same way. We can spool all the underground plumbing and do slope piping, by the way, in Revit, which is not heard of, or has been very difficult to do. Electrical, the product also does electrical, so we do all the MEP trades, so we can take and do processed electrical, where we'll pick everything up inside there and actually spool out electrical components. And then we can do design build. This is a University of Chicago job that started off as a design build job. Here you can see the risers going up, and that's real Revit content. And when they were ready for permit, that was 85% coordinated. There's the duct side of it, there's the design. That's what the contractor worked with to get it to that point. So there's several components to Siskiyou. There's a piping component, there's an electrical component, there's a duct component. We have fabrication reports, and we can send it out to plasma cutters. We send it out to the Vulcan cutting system, the cam duct system, and to the Vicon plasma cutting system. We do supports. We take these supports, these anchors, and send them right out to our Trimble machines. You can see right there, there's a hanger layout, design and fabrication. And again, sending that out to the Trimble partnered machines. We use a 360 workflow, which is kind of unique. We can do all the fabrication, get it out to the field. If something needs to change, we can send it right back to the office and update our models and show what the deviation was. So that's unique. Any questions? Anything? I'll be around. I have a booth. We're table number 12, so if you'd like to stop by and chat a little bit, I'll be here the rest of the afternoon. Thank you.